In 1902, near the town of Arcata in Northern California, a logging crew stood at the base of a coast redwood that had been growing since the year 1200. The tree measured 32 feet across at the butt, the swollen base where the trunk met the ground. It rose 340 feet into the fog, straight as a plumb line, without a single branch for the first 150 feet. The wood inside was worth a fortune. One tree could produce enough lumber to build 30 houses. But between the stump and the sawmill 14 miles away lay a problem that muscle and physics had to solve together. The felled log, after the top and branches were removed, still measured 24 feet in diameter at the thick end and weighed 287,000 pounds. That's 143 tons, heavier than a fully loaded locomotive. Too large to float, because redwood doesn't float well when it's green and waterlogged. And too heavy for any standard wagon or cart. Too massive for any team of animals anyone had ever assembled, and it had to move. Because if it didn't move, it had no value. It was just an enormous piece of wood lying in the forest, rotting. This is the story of how America moved the largest trees on Earth out of forests that had never seen a road. Using wagons built like ships, teams of animals measured in dozens, and railroads so temporary they were torn up and moved after a single load. The scale was beyond reason. The danger was constant, and the men who did this work invented solutions on the ground because there was no manual for moving something that weighed as much as a house. Let's start with the trees themselves, because nothing about the redwood logging industry makes sense until you understand what they were cutting. Coast redwoods, Sequoia sempervirens, grow in a narrow strip along the Pacific coast from southern Oregon to central California. They don't grow anywhere else on Earth. The climate has to be exactly right. Cool summers, wet winters, and most importantly, fog. The fog rolls in from the ocean almost daily, and the trees pull moisture directly from the air through their needles. That fog feeds them through the dry season and allows them to reach sizes that defy belief. In the 1850s, when American loggers first entered the redwood forest in force, they found trees that were older than European civilization in the Americas. Some had begun growing 2,000 years ago. Many were over 300 feet tall. The trunks were so wide that early photographs show men standing in undercuts, the notch chopped into the base of the tree before felling. And the notch itself was large enough to shelter a wagon. These were not trees in the normal sense. They were living structures, columns of wood so tall you couldn't see the top from the ground, so wide that the bark alone could be a foot thick. The wood was valuable for the same reasons the trees grew so large. It resisted rot. It didn't warp. It was lightweight for its strength, and it was beautiful, a deep reddish brown that darkened with age. You could use redwood for siding, for shingles, for framing, for tanks that held water, for anything that needed to last. And the market was exploding. San Francisco was booming. Los Angeles was growing. The entire West Coast needed lumber. But the redwoods were not in convenient locations. They grew in steep coastal mountains, in canyons choked with undergrowth, on slopes so steep you couldn't stand upright without holding onto something, and the nearest rivers were small, fast, and full of rocks. You couldn't float redwood logs the way you could float pine in Maine. The rivers weren't big enough and the wood was too dense. If you wanted redwood lumber, you had to cut the tree where it stood and then move the log overland to a mill or a railroad, and that meant solving a transportation problem that had no precedent. The first step was felling the tree. That alone was a multi-day operation. Redwoods were too large to cut from the ground. The butt swell, the flared base, could be 40 feet in circumference. Cutting through that much wood would take a week. So the fallers worked from springboards, narrow planks inserted into notches chopped into the trunk 8 or 10 or sometimes 15 feet above the ground. Two men, one on each end of a crosscut saw called a misery whip, would stand on these springboards and pull the saw back and forth through wood that was harder than most softwoods and filled with moisture. A saw cutting redwood would gum up with sap and sawdust every few minutes. The men would have to stop, clean the blade, resharpen the teeth with a file, and start again. Cutting a large redwood could take 3 or 4 days of continuous work, and that was just the back cut. Before that, they had to chop the undercut, a wedge-shaped notch on the side they wanted the tree to fall. The undercut was chopped with double-bit axes, each swing removing a chip of wood the size of a dinner plate. A good axeman could swing all day, but even the best crews needed a full day just to chop the undercut on a giant redwood. When the tree finally fell, the impact could be felt a mile away. Witnesses described the ground shaking. The sound was not a crack or a snap. It was a roar, a tearing noise as thousands of tons of wood peeled away from the stump and accelerated downward. The tree fell at an angle, the top hitting first, and the impact shattered the crown, sending branches the size of normal trees flying in every direction. The trunk would hit and bounce, sometimes breaking in half from the force, sometimes staying intact. When the dust settled, the fallers would approach and assess the damage. If the log had shattered, it was a loss. Broken wood was worthless. If it had stayed whole, the real work could begin. The log had to be bucked, cut into manageable sections, but manageable is a relative term. A redwood log 200 feet long and 10 feet in diameter was not movable, or it had to be cut into shorter pieces, usually 20 to 40 feet long, depending on what the transportation system could handle. Even a 30-foot section of a large redwood could weigh 60 or 80 tons. The bucking was done with the same crosscut saws used to fell the tree. 2 men, standing on top of the log, would pull the saw down through the diameter. It could take hours to make a single cut. Once the log was bucked into sections, the next problem appeared. How do you move it? In flat terrain, you could use skid roads, trails made from smaller logs laid crosswise like railroad ties, greased with oil or animal fat to reduce friction. Oxen or horses would be hitched to the log with chains, and the animals would drag it along the skid road to a central landing. But in the steep redwood country, skid roads only worked on moderate slopes. On steep ground, the log would slide out of control, crushing anything in its path. The solution was different depending on the terrain, and every solution was dangerous. On slopes, some operations used chutes, long V-shaped troughs made from split logs angled downhill. The log would be rolled into the chute and gravity would do the work. Men would ride alongside with crude brakes, wooden blocks jammed against the log to control the speed. If the log got away from them, if it accelerated too much, it would shoot out of the chute at the bottom and destroy whatever was in the way. Men died in chute operations. Crushed when a log jumped the chute. Killed when a log they were riding rolled and threw them into the path of the following timber. But the chutes could only go downhill, and not every log was uphill from the mill. For logs on flat ground or for moving timber over longer distances, the logging companies built wagons. Not normal wagons. These were structures. The wheels alone were engineering projects. A logging wagon designed to carry a single 100-ton redwood log had wheels 10 or 12 feet in diameter. The wheels were made from wood, reinforced with iron bands, and mounted on axles that were themselves logs, 2 feet thick, turned on a lathe to create a smooth cylinder. The wagon bed was a massive timber frame, built to support a load distributed over 30 or 40 feet of length. These wagons didn't carry multiple logs. They carried one log, one tree section, and the entire wagon was designed around that single piece of cargo. Loading the log onto the wagon was a feat of rigging and patience. The wagon would be positioned next to the log. A loading ramp would be built using smaller logs and timbers, then using block and tackle, multiple pulley systems, and sometimes a portable steam donkey, a small steam-powered winch. The log would be inched up the ramp and onto the wagon bed. This could take an entire day. The log had to be positioned perfectly, balanced so the weight was distributed evenly across the axles. If the balance was off, the wagon would tip or the axles would snap. Once the log was loaded and chained down, the wagon became part of the log. The two were a single unit, and that unit weighed as much as a small building. Now you needed something to pull it. Horses, oxen, mules, sometimes all three. The teams assembled to move giant redwood logs were the largest working animal teams ever used in North American logging. A standard freight wagon might use a team of 4 or 6 horses. A heavy load might require 8. The redwood wagons required teams of 20, 30, sometimes 40 animals. These were not random horses pulled from a farm. They were match teams, trained to work together, selected for size and strength. Draft horses, Percherons, Clydesdales, Belgians, animals that weighed a ton each. Oxen, even larger, slower but stronger, capable of sustained pulling that would break a horse. The teams were hitched in pairs, side by side, stretching out in front of the wagon in a line that could be 100 feet long. The teamster, the man who controlled this living engine, worked from the wagon or from alongside the team. He didn't use reins. You can't hold reins connected to 40 animals. Instead, he used voice commands and a whip, not to strike the animals. And though that happened, but to make noise, sharp cracks that signaled which pair needed to pull harder or ease off. The lead team, the horses at the very front, were the most valuable. They set the direction and the pace. If the leaders balked or turned the wrong way, the entire line would tangle. A good lead team could follow a narrow roadway, make turns, and stop on command. Training a lead team took years. The animals behind them just had to pull. And pull they did. Moving a 100-ton load on a wagon with wooden wheels over dirt roads required constant, sustained effort. The teams would lean into the harnesses, hooves digging into the ground, muscles straining. On flat ground, the wagon might move at a walking pace, 2 miles per hour. On an incline, the pace would drop to a crawl. The teamster had to watch for signs of exhaustion. A horse that stumbled could fall and take the rest of the team down. An ox that went lame had to be cut out of the harness immediately or it would be trampled. The roads themselves were built for this traffic. Logging roads in Redwood country were not trails. They were engineered paths, graded and cleared, sometimes 30 feet wide to accommodate the wagon and team. Curves were gentle because a wagon carrying a 30-foot log couldn't make a sharp turn. The turning radius was too large. Hills were avoided when possible. When they couldn't be avoided, the grade was kept shallow. A 10% grade was the maximum a loaded wagon could handle, and even that required the full team pulling at capacity. Going downhill was worse than going up. A loaded wagon on a downgrade would push forward, overrunning the team. The animals couldn't hold it back. So the wagons were equipped with brakes, massive friction brakes, wooden blocks or iron shoes that pressed against the wheels. The brakeman, a second worker riding on the wagon, would operate these brakes using a long lever. On a steep descent, the brakeman would lock the brakes and the wheels would skid, gouging the road. The friction was so intense the brake shoes would smoke. Sometimes they would catch fire, and the brakeman would have to release the brake, let the wagon roll, and reapply it before the speed built up too much. It was a constant, terrifying balance. Too much brake, and the wheels locked, and the wagon could tip. Too little, and the wagon would accelerate and crush the team from behind. The distances were not long by modern standards, but the pace was glacial. Moving a single log from the cutting site to the mill or the railroad siding might take 2 or 3 days. The team would pull for a few hours, then rest. The animals had to be fed and watered. The wagon had to be inspected for damage. The road had to be maintained. A rock in the wrong place could shatter a wheel. A washed-out section could strand the load. The operation was a crawl, a slow procession of men and animals and wood, moving through the forest at a pace that would frustrate anyone used to modern logistics. But it worked. Log by log, the redwoods moved. Some companies took a different approach. Instead of wagons, they built railroads. Temporary railroads. Logging railroads in the redwood forests were not permanent infrastructure. They were tools, built to extract timber from a specific area and then abandoned or torn up and moved when the timber was gone. The rails were narrow gauge, usually 3 feet between the rails instead of the standard 4 feet 8.5 inches, because narrow gauge was cheaper to build and could handle tighter curves. But for the largest logs, even narrow gauge wasn't enough. Some operations built special wide gauge spurs, rails set 6 or even 8 feet apart, to accommodate flat cars designed to carry a single massive log. The flat cars themselves were custom built. A standard logging flat car might be 30 feet long. A car built to carry a giant redwood log could be 50 or 60 feet long, with a bed made from timbers 12 inches thick. The car had no sides. It was just a platform on wheels. The log would be loaded using a steam donkey or a crane, rolled onto the car, and chained down. The loaded car, with a single log, could weigh 100 tons or more. Moving it required a locomotive, and not just any locomotive. The standard engines used on logging railroads were geared locomotives, machines like the Shay or the Heisler, designed for steep grades and sharp curves. These locomotives didn't move fast. Top speed was maybe 10 or 15 miles per hour on flat ground. Loaded, pulling a car with a 100-ton log, the speed dropped to a walking pace. But they could pull. The geared drive system gave them enormous torque, and they could haul loads up grades that would stall a standard locomotive. The railroads followed the terrain, snaking through canyons, crossing creeks on wooden trestles that were marvels of rough carpentry. The trestles were built from redwood, ironically, and using smaller trees to build the infrastructure to move the giants. Some trestles were simple, just a few supports spanning a gully. Others were massive, 100 feet high, spanning ravines, built without blueprints by crews who understood load and balance through experience. The trestle swayed when a loaded train crossed. You could feel the structure flexing under the weight. Engineers would stand at the base and watch, waiting for the crack that meant a support was failing. If a trestle failed under a loaded train, the locomotive and the log car would plunge into the canyon below. It happened. Not often, but enough that every engineer knew the risk. The locomotives themselves were maintained in the field. There were no repair shops in the deep woods. If an engine broke down, the crew fixed it on the spot with whatever they had. Boiler tubes were patched with makeshift gaskets. Broken drive gears were replaced with spares carried on the tender. Water was taken from creeks. Fuel, wood, or coal was hauled in on supply trains. The engineers and firemen who ran these locomotives were skilled machinists and mechanics, capable of diagnosing a problem by sound and fixing it with a hammer and a wrench. They worked in conditions that were loud, hot, and filthy. The cab of a logging locomotive was open to the weather. In the rain, you got wet. In the summer, the firebox turned the cab into an oven. And always, there was the knowledge that you were running a machine on tracks that were temporary, over trestles that were questionable, hauling loads that exceeded the design limits of everything involved. At the end of the line, whether it was a wagon road or a railroad, the logs arrived at the mill. The mills in Redwood country were sized to match the timber. A standard sawmill might have a carriage, the platform that holds the log and feeds it into the saw, that was 20 or 30 feet long. Redwood mills had carriages 60 feet long or more. The saws were the largest available, circular saws 8 or 10 feet in diameter, spinning at speeds that made the teeth blur. Band saws, long loops of steel with teeth, running on wheels 10 feet across. The mills ran on steam power or water power, and the noise was constant. The scream of the saw biting into wood, the crash of slabs falling away, the rattle of chains and conveyors moving lumber. The sawyers, the men who operated the saws, had to make decisions in seconds. Where to make the first cut, how to position the log to get the most lumber. Redwood grain could be unpredictable. A log that looked perfect on the outside could have a twisted grain or a hollow center. The sawyer had to read the wood and adjust. A mistake meant wasted lumber, and wasted lumber meant lost money. The sawyers were paid by production, so speed mattered. But speed without accuracy was expensive. The best sawyers could process a giant log in a few hours, turning it into stacks of dimensional lumber, beams, siding, shingles. The waste, the slabs and sawdust, was burned or dumped. In the early days, sawdust was just piled up near the mills, mountains of it, slowly composting or catching fire. The scale of the redwood logging industry at its peak is hard to comprehend. In the 1880s and 1890s, hundreds of millions of board feet of redwood were cut every year. The forest, which had covered over 2 million acres, was being reduced at a rate of tens of thousands of acres annually. Entire groves, trees that had stood for 1,000 years, were gone in a season. The loggers didn't see it as destruction. They saw it as harvest. The trees were a resource, and resources were meant to be used. There was no concept of sustainability, no replanting, no management. You cut until the forest was gone, then you moved to the next valley. The human cost was measured in injuries and deaths that were accepted as part of the work. Falling trees killed men. Widowmakers, broken tops that hung in the canopy and fell without warning. Barber chairs, when a tree split vertically and the butt kicked back with lethal force. Men were crushed by rolling logs, killed in wagon accidents when a load shifted or a wheel broke, injured on the railroads when a log rolled off a flat car or a trestle collapsed. The hospitals in the lumber towns treated a constant stream of trauma, crushed limbs, broken backs, men who survived but were crippled and could no longer work. There was no workers' compensation, no disability. If you were hurt badly enough that you couldn't work, you were done. Some companies had funds that would pay a small amount to a widow if her husband was killed on the job. Most didn't. You took the job knowing the risks, and if it killed you, your family buried you and moved on. The animals suffered too. Horses and oxen worked until they broke down. A horse with a broken leg in the woods was shot and left where it fell. An ox that could no longer pull was slaughtered for meat. The teamsters, and many of whom spent more time with their animals than with people, developed bonds with the teams. A good teamster knew each animal by name, knew which ones were steady and which ones were temperamental. When an animal died, it was a loss, not just economic, but personal. But the work continued. There were always more horses, more oxen, brought in from farms or ranches, trained just enough to pull and put into harness. By the early 1900s, the technology was changing. Internal combustion engines were starting to appear. The first gas-powered tractors were being used in agriculture, and it didn't take long for logging companies to see the potential. A tractor didn't need to be fed. It didn't get tired. It didn't die. By the 1920s, steam donkeys were being mounted on tracked crawlers, creating the first mobile yarders. By the 1930s, trucks were replacing wagons and railroads. A truck could haul a log faster, farther, and with less infrastructure. The roads had to be better, but building roads was cheaper than building railroads. The logging railroads were torn up. The rails were sold for scrap. The locomotives were retired or sold to other operations. The era of the horse team and the logging railroad was ending, but the giant logs kept coming for a while longer. In the 1940s and 50s, photographs document trucks hauling single redwood logs that dwarfed the vehicles. A log 12 feet in diameter loaded on a trailer, the truck itself looking like a toy underneath. These were the last of the giants. By the 1960s, the old-growth redwood was mostly gone. What remained was protected, turned into parks, preserved as monuments to what had been lost. Like the second growth forests were managed, logs selectively, replanted, but the trees would never reach the sizes they had before. A redwood can live 2,000 years, but only if it's allowed to. The logging industry had taken a forest that had grown for millennia and reduced it in a century. What remains today are fragments, old-growth groves and parks where you can walk among trees that survived the logging era, stumps, massive stumps, 15 and 20 feet across, slowly rotting in the forest, some of them with new trees growing out of the top, logging equipment in museums, a wagon with 10-foot wheels, a narrow-gauge locomotive, photographs, thousands of photographs documenting the scale, men standing next to logs dwarfed by the timber, teams of horses stretching into the distance, when flat cars loaded with single logs so large the men standing on them look like children. These images are the record of an industry that operated at a scale that's hard to believe, even with photographic evidence. The men who did this work are gone. The last of the old-time redwood loggers, the ones who worked with horse teams and handsaws, died in the 1980s and 90s. A few oral histories were recorded, old men describing the work, the cold mornings, the danger, the satisfaction of moving a log that weighed more than a house. They didn't romanticize it. It was hard work, dangerous work, work that destroyed a forest, but it was also skilled work, and there was pride in that. Pride in being able to control a 40-horse team, pride in setting a choker on a 100-ton log and watching the steam donkey pull it out of a canyon, pride in doing something that most men couldn't do. The environmental legacy is complicated. The redwood forests will never be what they were. The biodiversity that existed in the old growth, the understory plants, the animals that depended on the structure of ancient trees, much of that is gone. The second growth forests are different, thinner trees, less complexity, but they're growing. And in the protected groves, the remaining old growth stands as a reminder of what was lost and what can be saved if we choose to save it. The engineering legacy is clearer. The solutions developed to move 150-ton logs, the wagons, the railroads, the rigging systems, influenced logging practices worldwide. The techniques refined in the redwood forests were exported to other timber regions. The geared locomotives designed for redwood logging were used in Appalachia, in the Pacific Northwest, in South America. The skills developed by the teamsters and the railroad engineers and the rigging crews informed industrial practices that extended far beyond logging. But the most lasting legacy is the wood itself. Redwood lumber from the logging era is still in use. Buildings constructed in the 1800s with redwood siding still stand, the wood barely weathered. Water tanks built in 1900 are still holding water. The wood has outlasted the men who cut it, the animals that moved it, and the companies that milled it. Walk through San Francisco or Los Angeles, and you're walking past redwood that was cut 120 years ago, moved by horse teams and logging railroads, sawn in mills that no longer exist. The wood is the monument, not to the industry, but to the trees, to the forest that was sacrificed, and to the scale of human effort required to move something that nature spent centuries creating. The redwood forests stood for 2,000 years. We cut them in 100. The logs weighed 150 tons. We moved them with horses, rails, and human ingenuity. The cost was a forest. The legacy is the wood. And the lesson, if there is one, is that scale cuts both ways. We can accomplish staggering things, but what we accomplish and what we destroy are often the same.